Hi everyone, welcome to KidSafe Food Analyzer, an AI-powered application built by parents for parents to make informed food choices easier and safer. This app helps parents quickly analyze whether a particular product is good, bad, or moderate based on the ingredients without you having to go through the complex ingredient jargon. Here's what we're going to cover today. What the problem is, which I just spoke about, who the target audience is, what the proposed solution, followed by a demo. What the problem statement is. If you are a parent, you'll relate to what I'm currently talking about. You walk into a grocery store aisle or a supermarket aisle and you see 100 plus items. You have no idea what to take because the ingredient lists are complex. And for you to understand that, you will have to take your phone out. The first thing that you would do, go to ChatGPT, try to understand what the ingredients are. It tells you whether you can take it or not, but there's no middle ground. Now, on top of it, if your child has allergies, it's altogether a different ballgame because the kind of food that you give your kids can be life changing. I have two kids of my own, so I personally feel I've faced this exact problem many times. So, who's this app for? It's basically for parents. You don't have to be a parent to use it. You can also be health conscious person, and especially for parents who have kids with allergies. What are the key challenges that parents face, right? Um, let's quickly summarize. Time constraints. Yes, I spoke about opening the app, opening ChatGPT, and then asking it, but it still gives you like a lot of technical jargon and the terminology we spoke about. Who heard about nitrates, BHAs, PHDs? Let me not even get there. Many products have artificial additives, and there are, even though they say natural flavor, but we don't know what the natural flavor is. And the FDA has this amazing document that it's 250-page document that they expect us to read. Ironically, that very same document acts as our input dataset for us. What the solution is. I've built this app called KidSafe Food Analyzer that takes the FDA approved document, the FDA document that we spoke about, this document. This document is around 132 page long, and FDA expects you to read every single page to come to a conclusion. Now, here's the solution. This app, let's now, before we get into the app, let's look at what this app makes it easy for you. It gives you instant ingredient analysis. I've pre-compiled over 100 items wherein which we're going to see. It categorizes them into easy, good, moderate, or bad. The reason why I was talking about pre-computing is because most of the times, if you go to Costco, you would understand that you would not get cell phone reception. So having pre-computed results is a game changer. And it also breaks down the ingredients as per allergies. And it also has a chatbot and a surprise aspect at the end. Um, Live demo, we spoke about the product selection. Let's get into the demo. This is the app. This is the homepage, and it has over 109 products broken down across 18 categories. Now let's pick one. Let's say the bad beverages. In beverage, let's pick Coke. As you can see, the results are spot on. It's super fast. It tells you it's bad. It also gives you a reason as to why it's bad. This is caffeine is a common allergen, so it's highlighted in yellow. Now, this ChatGPT can give you. It gives you all of it. If you have patience, please read through it. But you want to ask questions based out of it. Now, you can ask, now this is context aware. So it does not go straight up get the results from ChatGPT, but instead it says, can a 5-year-old drink this? Now it goes through it looks at Coke and then goes through, makes a call to OpenAI API and then gives you the ingredient, gives you the answer. It tells you that overall Coke is bad, and it also gives you the reason. But again, come on. I'm a parent. My kids would not listen to me, but my kids would listen to an animated character say why it's good or why it's bad. There you go, our new friend. If you have watched Netflix K-pop series, you know what I'm talking about.
Heads up. This is bad for kids. Contains harmful artificial ingredients. Let's find something better.
You get the gist. Now, the video category is broken down into good, bad, and moderate, and you have 3 different videos for it, and you also have voice that overlays on top of it. Pretty common stuff, right? You've seen an item, but you want to find out if Coke is better, or you want to compare it against any other rivals, right? So let's go add to compare. You've added this, and you want to compare Coke with Pepsi. Yay. Also bad. Let's add this, but let's compare this with something that has good ingredients. Good. Okay. Let's add to compare. Now, if we go back to the comparison mode, it gives you the comparison between the 3 items that we just selected. You can make decisions here. Again, pretty common stuff. Now, you can also add items to, say, this particular item. Since you know that this is good, which is the Tropicana Pure Premium Orange Juice, you can also add it to your favorites. You can also add it to your shopping list directly. Or if you want to share it with your friends, you can also directly share common stuff. Now that you have seen, you can go to shopping list, you get all the items. Now, a common question. The pre-computed dataset that I was talking about only has 109 items. But what if you want to go look at an item that's not out there? Let's take my favorite Oreos. Now, this makes a call to OpenAI API, gets the results. Since now, as you can see, the user experience up until now, for the pre-computed dataset, you were able to get the results instantly, as opposed to now, wherein you're having to wait for like good 10 to 15 seconds. There you go. Oreos are bad. It follows the same thing. Now you have the results. Now, pretty much you can also, in addition to the name of the product, you can also give it the exact same ingredients. It'll still work. Let's say you have multiple items. It searches through the database and it gives you all the list of items. It's all there. Let's go back to the presentation in the interest of time. What the infrastructure is. The front end of the app is written in is hosted in Vercel, and the back end is hosted on Render. Front end is written in React, whereas you get all the items that are in there. For LLM calls, it uses OpenAI APIs, and for web search, it uses a Tavili. Audio part of it is this audio, and the video part is where I spent a lot of time. I'll get into it now. Now, the primary, to sum it up, the FTA document that you just saw acts as the primary data set, and the results are all pre-computed. For chunking, I used the document is broken down into 132 pages, one for each chunk. And I used, if you look at this, Ensemble gave me better results, so I went with Ensemble. What are the lessons learned from this? It's not the data per se, or it's not the model complexity per se, but it's the data. It's garbage in, garbage out. The better the ingredients are, the better the output. And user experience. You have seen from the previous example, for the time that it takes to give you the pre-computed results, as opposed to you having to wait for the results for Oreo. Yes, the data is stale, but the plan is to have a batch job of sorts, which would pre-compute it once a week or once every 2 weeks, and then give you the results as an update. Video generation in real time is super hard. The next steps is to have a mobile app, and to have, like I just spoke about, the current input is only 100. It can go to any items. Yes, you have the option to again search, but the more the better. That's it. I thought this could help a parent. If it can help me as a parent, my vision is that it can help anyone, any other parent that is going through the same set of troubles. Thank you. Thanks for your time. Hi, everyone. Welcome to